Question 422. In this question, we need to find the SS in each rod. We have steel rod here, we have bronze rod here. For finding the stress in each rod, we can write sigma is equal to P divided by A. A is the cross-sectional area of the steel rod, and area of the bronze rod we have based on the question data. It is necessary to find the P, the internal force inside the steel and internal force in bronze. You know that for finding these internal forces, it is necessary to analyze this beam AB. The number of the support reactions for this beam AB, is that we have the pin connection at A, we have one steel rod here, one bronze rod here. It means that altogether we have 4 support reactions. And equations of equilibrium, the number of equations of equilibrium for one beam, actually the number of equations of equilibrium, you know that we have sigma fx is equal to 0, sigma fy is equal to 0, and sigma m is equal to 0. That's why we have the equations, 3 equations of equilibrium. It means that the number of support reactions and the number of unknown is more than the equations of equilibrium. This beam, it means this beam is statically indeterminate. For analyzing the statically indeterminate, the equation of equilibrium should be supplemented with additional equations. In fact, we need enough compatibility equations so that the sum of the equilibrium equations and the compatibility equations is equal to the number of unknowns. For analyzing this beam, at the beginning, we write based on the equation of equilibrium, sigma MA is equal to 0. We assume clockwise direction is positive. That's why we can write, for example, if we assume at the beginning, if we assume the internal forces inside, the internal forces generated, the internal forces generated inside of the steel rod and the bronze rod is upward. That's why we can write here sigma m is equal to 0. If we take a moment around A, we can write, for example, minus 0.6 this arm times P steel minus 1.6 times P bronze plus 60 times this weight 2.4 is equal to 0. After the simplification, we can say that P steel plus 1.6 P bronze is equal to 144. We call this equation number 1. We found equation number 1 based on the equation of equilibrium, sigma m A is equal to 0. Because this beam AB is statically indeterminate, that's why we need to add some additional equation based on the compatibility concept or equation. Compatibility equation is based on the formation of the structures. That's why we can write one equation based on the deformation that happens in the steel and bronze. Look here, based on the question data, the beam AB is perfectly rigid beam. That's why after the deformation, it remains the straight line and there is not any bending here in this beam. We have delta bronze, deformation in the bronze, and delta steel here. If we draw here again, in the original case, beam AB, after the deformation, here we have delta bronze and delta steel, 0.6 and 1 meter. Based on the triangle similarity rule, we can write delta BR, deformation in the bronze, divided by this length, 1.6, is equal to delta still divided by 0.6. We found this actually relationship based on the compatibility equation, and we can say delta bronze is equal to 2.67 delta steel. We call this equation number 2. So far, we found one equation based on the equation of equilibrium sigma A is equal to 0, and using the compatibility concept or equation, we found another equation, equation number 2. There is a relationship between the deformation in the bronze and the steel. Now, you know that the deformation of the linear elastic material under the axial load, delta, is equal to PL over AE. Please pay attention here. Sometimes we show that the formation of the linear elastic material under the axial load, delta or delta L. It really doesn't matter. It's the same. Here is the delta for the deformation, and this symbol is sigma for stress. Please pay attention to these symbols. Now, for delta BR, we can write P bronze, L bronze divided by A bronze, E bronze, delta S steel. We can write P steel, L steel divided by A steel, E steel. In the equation number 2, we can write, for example, P bronze, L bronze divided by E bronze, A bronze is equal to 2.67 P steel, L steel, A steel, E steel. P bronze and the P steel are unknown. That's why we can write here P bronze. L bronze is equal to 2 meters. We convert to millimeter divided by A bronze is 250 based on the question data we have, and E bronze is 80 gigapascal. We convert to megapascal. 80 is equal to 2.67. P steel is unknown. L steel, the length of the steel, is equal to 1 meter. And A steel is equal to 450 times 200 times 10 to the power 3. 200 gigapascal, we converted to megapascal. If we simplify this equation, we can find this PBR is equal to 0.297 P steel. We call this equation number 3. Now, if we look at the previous page, we found one equation, equation number 1, based on the equation of equilibrium. Now, we have another equation, 2 equations to unknown. Using equations, using equation 1 and 3, we have 2 equations to unknown. We have PBR is equal to 39.07 kilonewton, and the P still is equal to 133.95 kilonewton. We found, actually based on the equation that we found based on the compatibility equation, we put the numbers here, and finally we found equation number 3. Using equation number 1 and number 3, we found PR and PS seal. It means that we found internal force in the brass, in the bronze, and in the internal force in the seal. After finding the internal force, for finding the stress in each member, it is we can simply write sigma BR is equal to PBR divided by ABR is equal to times 1000 kilonewton to newton, and ABR is equal to 250. Sigma steel is equal to PS steel divided by AS steel. That's why we can write 100.95 times 1000 divided by AS steel 200. AS steel is 450. That's why the sigma BR is equal to 159.12 MPa, and sigma steel is equal to 297.67 MPa. This is the final answer. Let's review the solution again from the beginning. The question is that find the stress in each rod, stress in the steel rod, stress in the bronze rod. Because this beam is statically indeterminate, the support reactions or the number of the unknowns are 4, and the number of equations of equilibrium are 3. This beam is statically indeterminate. For analyzing the statically indeterminate beams and the members, we need to add additional equations to the equations of equilibrium. Here we can use the compatibility concept or equation based on the deformations in the structure. Based on the equation of equilibrium, sigma A is equal to 0, we can find equation number 1 here. Based on the triangle similarity rule, we can find the relationship between the formation of the steel and bronze here. We can find the equation number 2. We know that delta, the deformation in the linear elastic members under the axial force, is equal to PL over AE. That's why if we write this equation, if we put this equation inside equation number 2, we can write here PBR, LBR divided by ABR. ABR is equal to 2.67 PS seal, LS seal, AS seal, ES seal. And finally, we can find the equation number 3. Using equation number 1 and number 3, we have two equations, two unknown. We can simply find PBR and PS seal. After finding the internal forces, for finding the stress generated inside these rods, we can write sigma BR is equal to PBR divided by ABR. Sigma seal is equal to PS seal divided by AS seal. Finally, we can find sigma BR is equal to 159.12 MPa, sigma seal 297.67 MPa. Next question. For this question, we have the composite column under the axial force. What is a composite member? Composite member is made up of two or more materials. For example, we have different materials. Here you can see we have a steel core and brass shell. Under the axial force, here is the axial force. Again, for analyzing the composite members, equilibrium and compatibility equations are used together for analyzing the behavior of these members. We can write at the beginning one equation based on the equation of equilibrium. Sigma Fy, for example, is equal to 0. You can see that the total force is applied over this member is supported by a steel core and brass shell. That's why we can say that 60 kilonewton, the force is applied, is equal to P steel plus P brass. Equation number 1. Equation number 1 based on the equation of equilibrium. Equation number 2 based on the compatibility equation, CE. You know that these two materials have been stuck together very well. That's why they're acting as a one member. And the deformation in each member is a similar of the another material. For example, the deformation of each material is the same as another material. For example, we can say that deformation delta steel is equal to delta brass. Because when we apply the load, the deformation that happens in the brass is the same as a steel. We call this equation number 2. Again, we know that delta is equal to PL over AE. Delta steel is equal to P steel, L steel, A steel, and E steel is equal to P brass, L brass, and A brass, E brass. Because L steel is the same as L brass, they can be removed here. P steel and P brass are unknown. What is the question? Actually, in the part A, we need to find the normal stress in the brass shell. For finding the normal stress, sigma is equal to P over A. It is necessary to find the P BR. P steel is unknown. P steel is unknown, divided by A steel. A steel, the area of the steel core is equal to 220 times 20 is 400. 400. E steel is equal to 200 gigapascal. 200 gigapascal. PBR is equal to ABR. For finding the ABR, we can calculate here. The total cross-sectional area is equal to 30 times 30. Here is 30 times 30 minus this area 400 is equal to 500. That's why the ABR is 500 times EBR. EBR is equal to 105 gigapascal. And after the simplification, we can write, for example, here P steel is equal to 36.23 after the simplification, we can find P steel is equal to 656 P, oh sorry, here PR is equal to P S 656 P S. We call this equation number 3. Equation number 3. Again, you see that we have equation number 1 here, equation number 3 here, 2 equations, 2 unknown. Using equation 1 and 3. Equation 1 and 3. We can find P SL. P SL is equal to 36.23 kilonewton, and PBR is equal to 23.77 kilonewton. For finding the normal stress in the brass, we can simply write in the brass is equal to P brass divided by A brass. 23 kilonewton to newton divided by A brass is 500 millimeter squared. That's why we can say sigma brass is equal to 47.54 MPa. Part A. We found that internal force, the stress, the normal stress in the brass. For part B, what is the question for part B? Here. Part B, the corresponding deformation of the assembly. At the beginning, we told that the deformation in the brass and the deformation in the steel core is the same. That's why for finding the deformation of the assembly, it is just necessary to find the deformation of the steel core or brass shell. For part B, we can write delta. Delta brass is equal to P brass, L brass, A brass, and E brass. Delta brass is equal to P brass. We found that P brass here 23.77 kilonewton to newton times L brass. The length of the member is 250 millimeter divided by A brass is 500 times E brass 105 gigapascal to megapascal, and delta brass we can write 0.1132 millimeter. If you find, for example, the delta SL, PSL, LSL, and ASL, ESL, you can find delta SL exactly the same answer. Here is the answer of the section B. Let's review the whole solution. The question was that find the normal stress and the deformation of the assembly in this system. This member is a composite member. It is made of 2 different materials, brass and steel core. Based on the equations of equilibrium, sigma Fy is equal to total force, axial force is applied is supported by PSL plus P bras. And based on the compatibility equation or concept, we can write a relationship between the deformation of the bras and SL. Because they have been stuck together, they're acting as a one member on the axial force. That's why we can say delta SL is equal to delta bras. If we put delta SL and delta bras here equations, and after the simplification we can write equation number 3. Now we have equation number 1, equation number 3. Here 2 equations, 2 unknown. We can find PSL and P bras here. After finding the internal force, we can find stress generated inside the member. Sigma bras is equal to P bras divided by A bras. Sigma bras is equal to 47.54 MPa. For part B, we need to find the deformation in the assembly. Delta BR is equal to PBR, LBR, ABR, EBR. For example, if we find the delta BR, we can say that 0.1132 millimeter. And if you calculate the delta SL, you can find the same answer. It means that the formation of the bras and the deformation of the SL is the same.